Okay, find derivative by the limit process, or the definition of derivative. So the first thing I'm going to do is go ahead and write that out. The derivative, f prime of x, is equal to the limit as delta x, or h, goes to 0 of f of x plus delta x minus f of x over delta x. Okay, so what is x plus delta x for this particular problem? Well, that's going to be just plug in x plus delta x into your function. So that's equal to, come over here, the limit of, or the limit as delta x goes to 0 of 1 over x plus delta x minus f of x, which is 1 over x, all over delta x. All right, so now I got some algebra to do. This is one of those cases where I got a complex fraction. So in algebra class, you learned how to deal with these. I'm going to multiply by the least common denominator of these smaller fractions, or the fractions that are in my overall numerator. And the least common denominator is the product of the two. Okay, and I haven't taken the limit yet, so I still say limit. And then basically I'm going to run this guy through here, and here, distribute it. So for the first product, the x plus delta x goes away, and that leaves me with x. And then I run it through here. The x's go away. It leaves me with x plus delta x. Now you got to be real careful. Include those parentheses, right? We're going to subtract the result of this product. So I'm subtracting, if the x's go away, then I'm subtracting x plus delta x. The sum x plus delta x. In other words, I'm going to have to do a distribution step, and this is going to become negative. Okay, that's important. In the bottom, I'm not going to multiply. I'm not going to run anything through. I'll leave it in its factored form, if you will. And then I run my negative through, and up top, I'm going to get x minus delta x. So the limit as delta x goes to 0 of negative delta x. And on the bottom, I got a positive delta x. Those three terms, and this goes away, and I end up with a negative 1 up top. All right, so a common mistake would be to forget to run the negative through and end up with a positive 1 up top. And now finally we can take the limit as delta x goes to 0. Notice I write limit the whole way as we go until I take the limit. Basically we've just been doing algebra the whole time. And now I take the limit, and that goes away, and I get x times x in the bottom, and that's x squared, and I get my derivative. Okay, let's try one more. This is a rational function. Square root of 2 minus x. So by the g prime of x, by the definition of derivative, is the limit as delta x goes to 0 of the square root of g of x plus delta x. So in other words, for g, I replace x with x plus delta x, minus g of x, which is 2 minus x, all over delta x. Okay, let's do some algebra. In this algebra step I'm going to do is multiply by the conjugate, right? We're going to rationalize the numerator. When I rationalize the numerator here, I rewrite this expression, the first part of my difference, 2 minus x plus delta x, and then the conjugate of this difference is the sum of those two terms. And then in math, if I multiply the numerator by a number, I got to do the same in the denominator. It's a trick we like to do a lot. Multiply by 1. This is just a form of 1. Okay, so now the reason I'm doing this is going to simplify my numerator a good bit. Remember, the goal here is to deal with this guy, right? Because I can't evaluate the limit by plugging it in directly, but once I do some algebra, I can manipulate it in a way that should hopefully cancel out. So that's the goal. So I haven't taken the limit yet, so notice I still write limit. And then when you square a square root, you end up without the root sign. And then when you multiply conjugates, you don't have to do the whole foiling, right? It's just the first two terms, the last two terms, and then a negative times a positive is a negative. And then again, be careful with this guy. Make sure to include those parentheses because we're going to have to distribute that negative through. And like the last one, I'm not going to deal with multiplying yet because I'm hoping that this will go away and then I can evaluate the limit. So that's going to be square root of 2 minus x plus delta x plus square root of 2 minus x. And now let's see if we can save a little bit of writing. I'm going to distribute that. So if you distribute that, you get negative 2 plus x. That's important. So 2 minus 2 is 0. Negative x plus x is 0. And we'd have to distribute that guy too. In other words, this term has to be a negative. So I end up with only a negative delta x in the top. And, oh, I didn't take the limit yet. So I got to make sure that this is equal still to the limit as delta x goes to 0. In the top, I end up with a negative delta x term. Everything else went away. And then we got that del x term in the bottom, and then these two roots. That's a 2 minus x. That's a 2 minus x plus delta x. Sorry, it's a little messy. I just rewrote that in this small space. And now these go away. I end up with a negative 1 up top. And I'll go ahead and take the limit. So I don't have to write limit now because I'm going to take the limit, plugging in 0 here. And of course, you end up with a 2 minus x plus a 2 minus x and a negative 1 up top. So 2 minus x plus 2 minus x is 2 minus x's. I should be saying root. Root 2 minus x plus root 2 minus x is 2 root 2 minus x. And this is your derivative.